So this is the paper from the magnetics.com. You guys can go to that site and see that yourself. I'm trying to apply that to what this magnetic configuration is on this machinist parallel. And I was looking at presenting this cog as this part. So, I mean, in effect, right? Like this. So, the only difference is on the front two magnets, on the left and right magnet, I guess, with the center magnet, they're split and they spread out onto the inside of the bar so that there is, let's see, this one shows a south and a north, so the front pole, whatever this pole is going to be the opposite of this pole, which is why I have this, which shows the poles, right? So south, this should be a north, should be a south, north, south. Anyway, so the thought occurred to me that remembering the spacing and the fact that these magnets on the other bar were actually up against each other, you know, pretty much like this, right? And this bar was about an inch shorter and slid up that way with everything set up that way. So if that was actually representing the two front magnets still, along with the single back magnet being the top magnet, right? If that's the case, then the spacing was approximately one magnet. It was 18 millimeters, right? In between each magnet pair, it was 18 or 19 millimeters. I think it was 18. It was a little bit shorter, right? Which is a little smaller, which means that the gap here would have been about the size of the magnet, a little bit shy. These are all 3/4 inch diameter, and the square ones are 3/4 inch square. They're all 1/8 inch thick. These are ceramic, and that's neo. So the parallel actually should have been about this, just that wide, and then the other magnet would have been here, and this would be a little more to that side. But I think the spacing offset is such that it's about one width, so when it comes in, it can't particularly center, right? Potentially. And that's why that one gap is there on the rotor, and then it has to be a little bigger gap. I don't know why. I would be speculating further there than I'm already speculating. Anyway, I was talking to Vinny and showing him the bearing as well, and that this one actually has a hole in the top, and I thought that it was spinning, and I was wrong. The hole is static and the bearing spins. So what it looks like I'll probably end up doing will be drilling an inch diameter hole, at least 3/8 of an inch deep into this nylon cut your own wheel from McMaster car. It's 4 inch diameter, 1 inch thick, and it's got the pilot hole already drilled. It's about an 1/8 inch diameter. So we'll drill that out an inch so that it sits around this part of the ring. And then I'll see about getting some Teflon washers to still use the screw hole. And the rotor will sit on the bearing, and the screw will just be held so that the rotor doesn't pop up off it. It'll just be there to hold that on. So I guess that's the forward direction. I need to see about finding a little bit narrower parallels. These are 2.5 inches wide, 1 inch deep, and I don't know what that is, a foot long, 14 inches long. They need to be only about 2 inches wide, maybe 1.5 inches wide. If it's only supposed to be exactly that, it would be only 1.5 inches, right? Because these are 3/4 times 2 for 1.5 inches, and then the other part here. So that would be, if it's 2 inches, you're going to end up still with a little bit of a gap in the middle. So I'd have to go look at the video again to make sure that that was what was really going on. Anyway, some other stuff to try. I need to just get also the magnet sets like this and see if I can produce any kind of the rotative motion. Presumably this would have to be set up in an array and then move toward the other magnet, which should cause the magnet to try and flip. And then the same kind of ideal here. Although you would move this to this and somehow this would cog. I'm not exactly sure how that is supposed to work, which is why we have to try it. So we'll see how it goes.